Let's continue with our demonstration of how Tanzu Greenplum can use Cloudian Hyperstore S3 compatible object storage for external tables. In this use case, we will show you how Greenplum can do in-place queries of datasets that are stored in S3 compatible buckets. For our demo, we're going to use datasets in both CSV and JSON formats. Let's first go into the Cloudian Management Console, or CMC, and we can display where the datasets are being stored. For this demo, we're logging into the CMC as a regular user, and we can see that there are buckets already defined here. Let's focus on buckets GP-CSV test 1 and GP-JSON test 1. Each of these buckets has a small dataset made up of 4 files or 4 objects in either CSV format or JSON format. Now, let's go to our Greenplum cluster. As a refresher, this cluster is made of 3 nodes, 1 master node and 2 segment hosts. So, I've gone ahead and logged in as root on the master node, and I'm going to switch user to the Greenplum user GP admin. So this user has all the permissions that are required to create databases, tables, etc. Everything I'm going to need for this demo. We'll check the PXF extension status here. As a refresher, the PXF extension is what Greenplum leverages to connect to S3 object storage. We haven't made any changes to the configuration that describes how Greenplum should connect to Cloudian Hyperstore, but if we did, we'd want to update the configuration on all the nodes with this command. Now we're going to create a demo database called Cloudian_demo2. Let's go ahead and log into that database instance. Once logged in, we'll define the PXF extension here. Then we can go ahead and define an external table that we will use to query our CSV dataset. I'm going to create an external table called PXF Cloudian CSV1, and it's going to use a specific CSV stored in my GP CSV test1 bucket. The file that we're going to use is file27.csv. Notice where we specified the external table name and the location, which points to the GP CSV test1 bucket and the file 27.csv, and that file happens to be in the CSV dataset folder. Also, the format is set to CSV, which will allow the data to be parsed properly. Now that the external table is created, let's do a very simple query. You can see the results of the query displayed here. Notice the number of rows displayed. Now let's do something similar, but this time we're going to create an external table that's going to include all the CSV files in the bucket. We'll create the external table PXF S3 Cloudian CSV2 here. Take a quick note that we're simply using the folder that contains the CSV files as a location parameter for this external table. Now let's query our new external table. The first thing you might notice is that the number of rows is larger than our first external table. Now this is because we're using all the CSV files in the folder as the data source versus a single file. Finally, let's do the same with the dataset stored in JSON format. We'll go ahead and create the external table first, and we're going to call this one PXF S3 Cloudian JSON1. Notice here that the location is set to GP JSON test1 bucket, and the data folder is JSON dataset. Just keep in mind the format parameter is going to need to be set to custom so we can parse the JSON files. Let's query the table. You can see the content of the table is now displayed. This concludes our demonstration on how Tanzu Greenplum can use Cloudian Hyperstore S3 compatible buckets for external tables. If you'd like to get more information on how Tanzu Greenplum and Cloudian Hyperstore can integrate together, please visit cloudian.com/greenplum.